Good morning, my dear students. Welcome to the chemistry class. In my previous class, we have discussed the acid-base equilibrium. Today, we will start from that ionization of water or ionic product of water. All of you know that pure water is a very bad conductor of electricity. Okay, for better conductor, water needs sufficient concentration of ions. Okay, but pure water is very slightly dissociated into hydrogen ion and hydroxyl ion. Okay, so you can write in this way that water is dissociating into very small concentration H plus and OH minus ion. Hope you can understand. Now here if we apply the law of equilibrium, we can write that K is equal to concentration of H plus into concentration of OH minus, that is the concentration of product by concentration of reactant. Okay. Now since the degree of dissociation of water is extremely small, so the concentration of this undissociated water molecule, okay, we can take it as constant. Okay, and if we want to calculate the molar concentration of water, so that will be the concentration of water will be, so water molecule already you know 18, so you know that the density of water is 1 gram per ml. So if 1 liter water is there, that means 1000 gram divided by 18, so it will be 55.55 moles per liter. Okay, so this will be the molar concentration of water. Okay, now here we have already written that K is equal to concentration of H plus and OH minus water, and if we consider this one as constant, so we can write K into constant, that is the concentration of water, is equal to concentration of H plus into concentration of OH minus. So this concentration of H plus and OH minus, this is called the ionic product of water, and here we are introducing a new term, that is Kw is equal to concentration of H plus into concentration of OH minus, and Kw is called the dissociation constant of water, or we can tell that ionic product of water. Okay, two ions are forming, the H plus and OH minus, so their concentration product is called Kw. Now value of Kw is constant as long as the temperature is constant. Okay, in your book it is given that at 22 degrees centigrade the value of Kw is equal to 1 into 10 to the power minus 14. Okay, this is the value of Kw, and if you want to write the unit, that will be the each concentration moles per liter, so it will be moles per liter whole square. Okay, so this is at 22 degrees centigrade. But if you increase the temperature, definitely the dissociation will increase. Okay, and its value will also increase. Okay, now whenever water is dissociating, okay, definitely the concentration of H plus and concentration of OH minus, that will be same concentration. Okay, so here we can write that concentration of H plus Kw is equal to 10 to the power minus 14. Okay, that will be the concentration of H plus into concentration of OH minus, but both are same, so here we can write that concentration of H plus into concentration of H plus, that will be equal to 10 to the power minus 14. Hope you can understand. Now from here, if we write the concentration as X, okay, X moles per liter, so then we can tell that 10 to the power minus 14 is equal to X into X, that means X square. X square is equal to 10 to the power minus 14. So if you calculate the value of X, so X will be 10 to the power minus 7. Okay, that unit you can write here, that is the moles per liter. That means the concentration of H plus and concentration of OH minus, that will be equal to the 10 to the power minus 7 moles per liter. Okay, now in your book one chart is given. Okay, we have already told you that degree of ionization of this water increases with rising temperature. Therefore, if you increase the temperature, the molar concentration of H plus and molar concentration of OH minus, okay, both will increase. And if you look at the on table is there in your book, there you will get at dissociation that constant, that means ionic product of water Kw value in 0 degree centigrade, 10 degree, 25, 30, 40. What you will observe that it will increase, the value will increase, okay. As you are increasing the temperature, definitely the value will increase. If you look at that 22, I have already told you that at 22 degree centigrade, okay, the Kw value will be 1 into 10 to the power minus 14. But if you look at 25 degree centigrade, it will be almost 1, but 1.008 into 10 to the power minus 14. That will be the Kw value at 25 degree centigrade. Okay. So the value of ionic product of water Kw depends only on temperature. Okay. So and this is constant, value is constant at a particular temperature. No matter that solution is acidic or basic or neutral. Okay, its value is always constant at a particular temperature. Suppose if you take an acid, okay, we add some acid, any acid you can take, okay. So if we add it to it or water, definitely the concentration of H plus will increase, okay. But definitely when there is the H plus concentration and increases, definitely the to keep it constant value of Kw, concentration of OH minus must decrease, okay. So here you can write that concentration of OH minus will be equal to concentration of OH minus equal to Kw by concentration of H plus. So definitely if you increase the concentration of H plus, definitely this value must decrease, okay, or will decrease. But if you add a base, okay, then what will happen? Okay, if you add base, any base you can add, okay, then definitely the concentration of OH minus will increase. Okay, if the concentration of OH minus increases, so definitely the concentration of H plus will decrease, okay, to get a constant value of Kw. Hope you can understand. So if H plus is increased, okay, concentration of H plus is increased, okay, and OH must decrease, understand? And if we increase the OH minus, definitely H plus will decrease, okay. That's the ionic product of water is significant for the determination of concentration of H plus in aqueous solution, okay. So H plus ions and OH minus ions are always present in aqueous solution, whether it is acidic or it is basic, okay, that you have to keep in mind. But in acidic solution, what is happening? Acidic solution, definitely concentration of H plus is greater than concentration of OH minus. So in acidic solution, concentration of H plus is always greater than concentration of OH minus. But in basic solution, that will be just reverse. Concentration of OH minus will be greater than concentration of H plus. And in neutral solution, definitely these two concentrations will be equal. That means concentration of H plus and concentration of OH minus both are equal. Okay. And already we have calculated that concentration of OH minus at 20 degree centigrade, that will be 10 to the power minus 7 moles per liter. So if the solution is neutral, okay, that means if the solution is neutral, then it is coming concentration of H plus to 10 to the minus 7. But if the solution is acidic, definitely the concentration of H plus will be concentration of H plus will be greater than 10 to the power minus 7 moles per liter. If the solution is basic, that concentration of H plus will be less than 10 to the power minus 7. And considering this fact, okay, in the year of 1909, okay, Sorensen, one scientist, okay, devised a scale. This scale is known as pH scale. Okay, to represent the hydrogen ion concentration, the pH of a solution is defined as the negative logarithm of its H plus ion or H3O plus ion concentration. Okay, so what is pH? According to Sorensen, minus log 10 base concentration of H3O plus, or you can write H plus. So this is the pH mathematical form of pH. Okay, but if you want to calculate the concentration of H3O plus, that will be the 10 to the power minus pH. This minus will go here, and that will be 10 to the power minus pH. All of you know the this thing, okay, from mathematics. Okay, now the hydrogen ion concentration of water at 22 degrees centigrade is 10 to the power minus 7 moles per liter. Definitely pH is log 10 base 10 to the H3O plus. Okay, so here we can, if you put the concentration of H3O plus, that is 10 to the power minus 7. So it is coming as 7. Okay, so this is the neutral condition. Okay, when pH is coming 7, that is the neutral condition. Hope you can understand what I am telling. Okay, now if the concentration of H plus is 10 to the power minus 3 moles per liter. Okay, concentration of H plus is equal to 10 to the power minus 3 moles per liter. Then pH value will be what? pH value will be minus log 10 to the 10 base 10 to the power minus 3. It is coming as 3. Sorry, the pH. So it is coming as 3. Now consider the 10 to the power minus 3 molar NaOH solution. Definitely concentration of OH minus will be 10 to the power minus 3 moles per liter. Okay, and all of you know that Kw is equal to concentration of H3O plus into concentration of OH minus. This is the ionic product of water. Now here what we are telling, okay, that Kw is equal to concentration of H3O plus and concentration of OH minus. So concentration of H3O plus, if you want to find out, so concentration of H3O plus will be equal to Kw by concentration of OH minus. Now if you have the value, okay, if you have the value of OH minus, so OH minus already I told that concentration is 10 to the power minus 3 molar, okay, NaOH solution. So here Kw we know that 10 to the power minus 14, and this is 10 to the power minus 3, so it is coming 10 to the power minus 11. This is the concentration of H3O plus. Okay, so here if you that moles per liter, here if you calculate the pH, so pH will come minus log 10 base concentration of H3O plus, that will be equal to minus log 10 base 10 to the power minus 11. So it is coming 11. Okay, so what we are observing here, that if the solution is acidic, its value is less than 7. If the solution is basic, its value is greater than 7. So if the concentration of H plus is equal to 10 to the power minus 7, then pH we are getting 7. So then the solution is neutral. If the concentration of H3O plus is greater than 10 to the power minus 7, then pH is less than 7. Okay, that means the solution is acidic. But if the concentration of H3O plus is less than 10 to the power minus 7, then pH is greater than 7. Okay, and the solution is basic. Okay, so from this concept, okay, we can tell that if the at 20 degrees centigrade, if the ionic product of water is 10 to the power minus 14, okay, so pH values varies from 0 to 14, and here Sorensen gave one scale that is called pH scale. It starts from 0 and ends at 40, and middle there is 7, that is called neutral. And if it is going above, here it is basic, and here it is acidic. Okay, so this is the pH scale. When it is 7, okay, so definitely it is neutral. But when you are going above 7, that 7.1 to 40, that is basic solution, and here less than 7, that will be acidic solution. Here if you consider 0 to 2 are strongly acidic, and 2 to 4 will be moderately acidic, but 4 to 6.99 around 7, okay, that will be what we can tell, that will be the very weakly acid. Here also, if you start from 7.1, okay, to 10, that will be weakly basic. And if you start from 10 to 12, that will be moderately base. And if you go from 12 to 14, definitely they will be strongly basic. Okay. Now another we can write that POH. Okay. POH is equal to same way as we are writing this, it will minus log 10 base concentration of OH minus. Okay, so this is the POH, and we can write also PKW. PKW is equal to minus log 10 base KW. That is the PKW. That KW. Okay. Now all of you know that KW is what? KW is equal to ionic product of water, concentration of H plus into concentration of OH minus. Okay, so from here you can write that minus log 10 base concentration of H plus minus log 10 base concentration of OH minus. So PKW is equal to what? PKW is equal to, we can write that KW at 20 degrees centigrade is 14, so it will be 40. And this is nothing but pH, and this is his POH. So we can tell that pH plus POH is equal to PKW, and pH plus POH is equal to also 40. Okay, here we are considering that temperature 22 degrees centigrade. 22 degrees centigrade. Okay, even at 25 degrees centigrade, KW is almost 10 to the power minus 14. Okay, 1.008 into 10 to the power minus 14. Hope you can understand. So in this way also we can show that pH plus POH is equal to 14. In the same way, we can write that pK is equal to minus log K. pK is equal to minus log 10 base K. Okay. So K is the what? Dissociation constant of the acid. In the similar way, you can write pKb is equal to minus log 10 base Kb. Kb is the dissociation constant of base, and here from here you can write that K into Kb is equal to we can write that Kw. Okay. So from here if you write that pKa plus pKb, pKa plus pKb, that will be equal to pKw. That you have to remember. Okay, in different numericals this is required. Okay. Now we will discuss about the measurement of pH. pH of a solution can be easily determined, but roughly with the help of a pH paper. Okay, pH paper is a mixture of containing mixture of dyes. Okay, at different pH it will show different color. Okay, but whatever value you will get, that is the approximate value. Okay, exact value you cannot get. But one digital instrument is there, that is called pH meter. From this digital meter, pH meter, you can easily calculate almost accurate value of the pH. And pH, some pH values list are given in your book, that also you have to remember. All of you know that human blood, okay, pH is 7.4, but pH of milk is 6.9. Every day we are eating different acidic substances in our stomach also HCl is secreted, but blood pH is not changing. And pH pH has a great importance, okay, in the agriculture, in the biochemical reaction such as digestion of food. Human blood is also pH is 7.4, and if pH changes only by 0.2 pH unit, okay, then it will result death. So you can understand how much important is the pH. So definitely some mechanism is there in our blood that we will discuss later. There is a buffer mechanism by which pH is maintained. Okay, and during food preservation also we need a definite pH value. Okay, and large number of qualitative and quantitative analysis, okay, in our experimental laboratory, okay, that are carried out at a particular definite pH. So that is why pH is very much important. Okay, in our life. Okay. Next, we'll discuss the limitation of pH scale. Definitely there is some limitation. Okay. And pH values of the solution do not give the exact idea of the relative strength. And pH, if you calculate, I will show you that 10 to the power minus 8 molar HCl. If you write that, if you use that formula, that pH is equal to minus log base 10 to the power concentration of H plus, you put this value 10 to the minus 8, definitely it will come as 8. Okay, 8 means basic, but it is not correct. Okay, if you calculate it properly, then it value will come near about 7. Okay, 6.99 like this. Okay, but what I am telling that less than 7. There are some solution that 1 molar HCl, that pH will be 0. But if you think about that higher molar, 2 molar, 3 molar, definitely you will get a negative pH value. But there is nothing wrong. Okay, you can get pH value. Actually, pH scale will also change if you change the temperature. Okay, whenever you are increasing temperature, definitely the KOW value will increase. Okay, and pH scale also will change. Hope you can understand what I am telling. Now I will show you some numerical. Okay, so that you can understand why I am telling. Suppose you have taken that one solution whose pH is 1. Evidently, why pH is 1? Concentration of H plus, we are writing 10 to the power minus 1. Then pH is equal to what? Minus log 10 base into concentration of H plus. Okay. So here if you are writing minus log 10 base 10 to the power minus 1. So it is coming as 1. So definitely it will be acidic in nature. Okay. So now if you dilute, definitely it may like this 10 to the power minus 4. That is the concentration of H plus. So definitely then you will get pH value 4. Then if you again diluted it, that is 10 to the power minus 6, then pH is coming. If you put this formula, then it is coming 6. And if you do it 10 to the power minus 7, concentration, molar concentration of H plus, definitely pH will come 7. But according to your scale, it is neutral solution. And if you are taking 10 to the power minus 8, then pH will come as 8. So it is basic. So if you take one acidic solution and if you dilute it, okay, continuously, then it will be basic. No, definitely there is something, okay, you have to understand. So let us calculate one problem. Okay, that is question is given that calculate the pH of 10 to the power minus 8 molar HCl. Now in this case, definitely you have to consider the dissociation of water. Okay, so suppose this is the water, it will dissociate into H plus OH minus, and here we are considering that X moles per liter, and this is also producing X moles per liter. Okay, as well as you are using HCl, so HCl will dissociate to give H plus Cl minus. So here H plus concentration is 10 to the power minus 8. Okay, so whenever you will calculate the pH, you have to calculate both. That means this X also you have to calculate. Okay, so here we will write that KW, that is the ionic product of water, is concentration of H plus into concentration of OH minus. So here concentration of H plus, you have to write this value is at 20 degrees centigrade 10 to the power minus 14, or you can 25 degrees centigrade, you can write that 10 to the power minus 14. So concentration of H plus will be here X plus 10 to the power minus 8. Okay, and X also X, OH minus concentration will be X. Okay, now here you have to generate one equation, that is X square plus 10 to the power minus 8X minus 10 to the power minus 14 is equal to 0. Now there will be no factor in this case, so you have to apply the you have to apply the Sridhar Acharya's rule. Okay, that you know that the rule, that is the here X is equal to minus B plus minus root over B square minus 4AC by twice A. If you put this formula, I am not showing you here, so you will get the value of X is equal to 9.51 into 10 to the power minus 8. Okay. Now concentration of H plus is what? Concentration of H plus x plus 10 to the power minus 8, and here you are getting 9.51 into 10 to the power minus 8 plus 10 to the power minus 8. Okay, so from here you will get 10 to the power 51, okay, into 10 to the power minus 8. All units are we can tell that moles per liter, or you can tell Raman per liter. Now here you have to find out the pH. So pH, if you calculate, that will be minus log 10 base concentration of H plus. Okay, so if you put this value, you will get pH is equal to 6.978. Okay, so in this way you have to calculate. Okay, so this is very important example. Okay, even if you take 10 to the power minus 9 molar HCl, it will never cross the 7, pH value 7. Okay, it will be very close to 7. Okay, that means it is acidic. Okay, dilute solution acid will be acidic. Okay, it will become neutral, or it will never become basic in nature. Okay, so that thing you have to apply. Now in your syllabus, many numericals are there in your book already solved. Okay, different types of numerical of pH, and pH based problem will come in your exam. This is in your syllabus. You have to practice from your book. Okay, and in live classes I will discuss some numericals. Okay, and also clear your doubt. So hope you whatever I have discussed today you can understand, and today after this, and thank you for watching.